This podcast is brought to you by VinZero. VinZero pioneers solutions and services to the AEC and manufacturing industries to support net zero targets. Visit vinzero.com to learn more about how organisations design, build and solve through digitalisation. From VinZero to you, welcome to our Think Future podcast series. Each week we'll share conversations with industry leaders from around the world to find out how they're thinking future. Subscribe to VinZero Think Future for access to more episodes, interviews and profiles. Tristram Carfrae is an award-winning structural engineer and designer and is Deputy Chairman for Arup. As one of 53 Arup Fellows, Tristram has been fortunate to work with many of the world's leading architects on projects where the structure forms a major aesthetic component. He has helped design 6 structures that have won special awards from the Institute of Structural Engineers, the world's premier structural accolade. He is passionate about the integration of engineering and architecture to provide the best holistic solution and has an unswerving commitment to designing better buildings that consume less resource, materials, energy, time and money, yet give more pleasure. Tristram, we are delighted to have you on the program. Welcome.
Thank you, Anthea. It's my delight and pleasure to be here today talking to you.
And we're very happy to have you on. I'm thrilled to hear about your achievements with your long career with Arup, if we could start there.
Well, I've been with Arup all my life, basically. I started at Arup in 1981, 41 years ago, and I have had such pleasure in this company that I can't imagine being anywhere else.
And your career spans some 41 years with that business, and over that time you've been responsible for the structure of a dazzling array of award-winning buildings. Can you share with us some of your favourite moments?
Well, 2 buildings in particular spring to mind. The first was actually I was in Sydney, so I spent half my career in Sydney and half in London. And when in Sydney, we got the opportunity to design the Water Cube, the National Swimming Centre for the Beijing Olympics back in 2008. So we were doing this in 2003, and actually it was the first time we sort of used computers from beginning to end. So we used the computer to design the building and also to document it and to deliver the information to the contractors. Then more recently, I have had the great pleasure for the last 7 years to help in the completion of La Sagrada Familia, Gaudi's amazing church in Barcelona. And I can't tell you how much pleasure it is to contribute in however small a way to such an amazing undertaking.
Arup is leading the way in sustainable development for the built environment under its We Shape a Better World purpose. What underpins this?
Well, lots of things underpin this, Anthea, but I think, in order of priority, we see, the number one priority facing us today is decarbonisation, is trying to mitigate climate change, to reduce it to the minimum we can possibly obtain. And then, of course, we also have to design a built environment which is then resilient to the climate change that will inevitably happen, the global warming that will occur. And then sort of next in line, if you like, and starting now, is thinking about being nature positive, about restoring biodiversity and making sure that every other species on the planet can also thrive.
So perhaps let's start with decarbonisation and in particular Arup's approach to whole life carbon data and how we can scale it for net zero.
So our view is that in order to decarbonise what we're doing, the first thing we have to do is to understand whole life carbon assessment on all our designs, whether those are new builds, refurbishments, adaptations, or whatever it is. Only by understanding the consequence of our decisions can we start making better decisions. And ideally, that would scale up from individual buildings or assets to make decisions across whole portfolios of assets. Which buildings should be demolished and replaced, which ones should be reused, which ones should be adapted, etc., and how to do it. The second bit is probably to optimise the operations of the existing buildings and extend their useful lives where possible. So that's then looking at individual assets that already exist. How do we retain them and make use of them rather than replacing them? Because obviously replacement, new construction, is far more carbon intensive than adaptation and reuse.
So how would you describe the purpose of whole life carbon assessments?
So the purpose of whole life carbon assessments is to get the information, the data on which you can decide which path of action to take. So you say, well, if we keep this building and refurbishment and or adapt it, how much carbon does that cost over the whole remaining life of the asset? Compared with if we build a new building in its place, demolish and rebuild, how much carbon does that cost over the whole life of that asset? And then we can decide which opportunity to go with. It isn't always based just on carbon. You have to look at the benefit that you're going to get from the two paths as well. So you have to look at sort of cost and benefit.
So since 2021, Arup have assessed 950 of their design assets across 30 countries, and that's an impressive result in a short period of time. What have been some of the insights?
Well, there have been many insights from doing this. So it's something we undertook, as you say, a year ago, because we realised that we didn't actually know the consequences of what we're currently doing in carbon terms. So the first thing is to understand what we've called our handprint, in other words, the impact of what we do for our clients, as opposed to our footprint, which is the consequence of what we do as an organisation. And what we've found is that our handprint, the impact we have on the external world through our projects, is at least 2 orders of magnitude, 100 times greater than the footprint of the organisation itself, including, that is, by the way, scopes 1, 2 and 3 for our organisation. So that's the first thing that we've learned. The second thing we've learned is that we are doing pretty well in terms of reducing operational energy and consequent carbon of our designs. That over the last 20 years, those have come down significantly. The third point, though, is we haven't yet significantly reduced the embodied carbon of our designs. So designs that are on the books today, which may have started 5 years ago, actually have no difference in embodied carbon to designs of 10 or 20 years ago. But the last point, which I think is the most important point, is we've also discovering that it's not that difficult to reduce embodied carbon by the 40%, which is our target for 2030, although it is a bit unclear as how to go further than that. So the first 40% reduction we think can be obtained relatively easily, and that is, to say, the immediate target.
So considering Arup's approach to whole life carbon data, how can we scale it for net zero?
So this is an industry-wide question. I can only really speak to what Arup is doing, but I think the whole industry has to come together and decide that this is what we want to do. In other words, we have to make carbon the most important objective of the next 5 years, I think. So then we should be well on our way. But we've all got to agree that our focus over the next 5 years is how do we design things that emit less carbon dioxide and stop polluting the planet before we reach a degree of climate change which would be disastrous.
So what has been the process for assessing the whole life carbon data across your portfolio thus far?
At the moment, we're looking at level 0 assessments, level 1 assessments, level 2 assessments. Level 0 assessments are really a bit sketchy. They just say, if we're going to design this sort of building in this location using normal methods, how much carbon would that emit? Level 1, start choosing the systems and saying, okay, if it's a concrete building using a VAV mechanical system or whatever, this is about the amount of carbon that would be involved with both its operations and its construction and its refurbishment. It goes all the way through for the whole life. But what we really need to do is level 2 assessments, where we assess the actual building, the actual design itself, in terms of all its structural components, all its facade components, all its mechanical components. And I'm talking about the systems as installed, as well as the prediction for its operations through its life cycle and any refurbishments and refits. Facades, for example, are probably only lasting 25 years or so before we've got to restore them. Hopefully we can restore them rather than throw them away and put on new ones, but we still have to allow for that carbon as well.
Is the process the same for infrastructure?
It is similar for infrastructure, but much more complicated. The problem with infrastructure is that the system boundary is difficult to define. So for the capital works, if you like, the construction, the process is very similar, although sometimes more complicated. But for the operational carbon, how much energy and or carbon you emit during operations, it's much more complicated because you've got to decide where your system boundary is. If you're designing a railway station here, how do you take into account the operations of the whole network, rail network? And then lastly, we have what's called user carbon, which is how the users of the railway either add to the carbon burden or reduce it. For example, if they're coming out of cars, which at the moment are carbon emitters, and into railways, they're probably saving carbon. But all of that is quite difficult to measure, predict, and put down in the books.
So thinking about the built environment, where would you say we are on the journey to decarbonisation?
I have the benefit as the Deputy Chair of Arup globally of having an oversight of sort of what we're doing in lots of different countries and territories around the world. And it's interesting that we are all in different stages. So in some places we might talk about carbon neutrality and be only referring to operating carbon and ignoring embodied carbon or fit out as well. Or we might say we're operationally neutral, which would be more accurate, or when we say net zero, how much of that is a reduction in the actual carbon and how much is done by offsetting, by buying carbon credits. These things are not yet actually sort of standardized or, common language. We say different things in different places. But I do believe that if we can all talk in terms of whole life carbon or WLCA, then at least we can all get onto a playing field where we're trying to take into account everything.
So Tristram, which is more important in the achievement of net zero, embodied carbon or operational carbon?
It's an interesting question, Anthony, because I think the answer is both, perhaps not very helpfully. But if we look back a bit, 20 years ago, operational carbon was probably 10 times larger than embodied carbon. But we've spent 20 years making great progress on operational carbon. We've reduced the energy that we're consuming in our assets, and we've changed the type of energy largely to electricity, and then we're beginning to see a decarbonised grid around the world, which then reduces the carbon still further. So we now see that embodied carbon, the thing that we thought was, relatively small, is now rearing its head as relatively large or equivalent. And the problem with that is there's no immediately obvious strategy for decarbonising from an embodied carbon perspective. There are no obvious material choices that reduce embodied carbon to zero. So the first step, which we've committed to do by 2030, is to reduce the embodied carbon by about 40%, which I'm pleased to say you can do relatively easily by sensible, efficient design and sensible material selection. So if you focus on both the efficiency of the design and the choice of materials, but without having to use radically different materials, you can reduce by that 40% that is the current target. And of course, to remember that there is a way of getting much lower than that, which is by reusing existing assets where the carbon has already been spent, if you like. The cost is already in the atmosphere. You're not contributing to it more if you simply reuse it.
What role is technology playing in reducing operational carbon?
So there are probably two main points here about how technology helps us with operational carbon. The first is it helps us model predicted performance and optimizing design during the design stage. So we have very good now simulation tools, energy calculations, CFD, all sorts of different ways of measuring and modeling operational carbon in the virtual world before you commit to making it in the real world. And then the second one is the control that we then have over the operations of the built asset, be it a piece of building or a piece of infrastructure. And increasingly, we're moving to an Internet of Things control, by which I mean the sensors and the operators within the building are all linked directly to the internet, to what we might call the cloud, where we can build operating systems that learn from artificial intelligence and machine learning to optimize not just the operation of individual buildings, but of whole districts or even whole cities. And then we can make serious differences to how much energy we use and therefore how much carbon we emit through the operations of the built environment.
Is there the same potential to use technology to help with embodied carbon?
There is, but it's a rather different approach. So for embodied carbon, you have to start with a lot of data. And that's what we were talking about earlier, that Arup has spent the last year trying to start that process. Once you've got copious data, you can establish benchmarks and understand what good looks like. It also helps you become carbon literate. You can start talking carbon, if you like, and understanding that environment. And from benchmarks, you can then establish budgets. So for whatever project it is you're trying to do, you can say, right, I think a reasonable target at this time in history for this sort of project is this amount of carbon. And then you can accurately and continuously assess your design decisions as you make them. So by simulating, the outcomes of your design, you're by basically measuring the amount of carbon in the structure and in the facade and in the fit out as you go through the design process, you can track your budget. Are you on budget or not? It's very, very similar to what we have always done for cost with cost plans and budgets.
Are you looking for a digitalisation and net zero partner to help you achieve your goals? Join the thousands of AEC and manufacturing customers globally who have turned to VinZero to start their journey toward a net zero future. With 32 offices around the world, VinZero can connect you to the right technologies and workflow processes so you can maintain your competitive position and increase profitability. Binzero has an industry expert to help you navigate the best pathway forward wherever you are on your digitalisation and net zero journey. Visit binzero.com to find out more. And what about embodied carbon in existing structures?
Existing structures are very interesting. We should be using them more and extending their life. But one of the difficulties is understanding the existing building performance and how much life it might be predicted to have. How do you get into the existing structure and say, is it safe? Is it not safe? Will it remain safe? But again, technology is coming to our help here. We can put accelerometers and other sensors onto an existing building. We can run lots and lots of simulations and say, what is therefore it likely? How is it likely to be performing if these are the results from our sensors? And therefore build up a probabilistic approach to analysis from which we could also make a probabilistic approach to how much life it has left in it. We can then monitor how they're performing actually thereafter. So we're doing this, for example, with big bridges at the moment, even from the day that they are built, because by monitoring the performance continuously, you can predict quite easily how much longer the bridge will continue to perform adequately or according to the brief. And another example is right now we've developed a whole platform for monitoring the performance of offshore wind farms, which surprisingly were only designed originally with a 20-year lifespan. So they're coming to their end of their theoretical life. But that doesn't mean they're actually coming to the end of their useful life. And again, by monitoring their performance, we can predict whether the foundations are still adequate, whether the shafts are still uncracked, whether the blades are rotating without deterioration. And indeed, if you sort of quite surprisingly, if you look at a whole wind farm, if you look at 50 installations, for example, you might find that 2 or 3 of them are performing less well than the remainder. But actually, it's very rare that you need the full output of the whole wind farm. So what you do then is use those turbines less and use other turbines more. So you sort of equalize the life of all the turbines over time and get the whole farm operating more efficiently. So it's very interesting what we can do by monitoring things and making better prediction.
So with the increasing demand for building the built environment globally, what percentage of the needs can be solved, do you think, by adaptive reuse of existing buildings or the relifing of existing buildings?
I'd hesitate to put a global percentage on it. In my experience in, say, the UK, probably 50 or 60% at least right now. But actually, every situation is different. Now, before I get to that, the circular economy springs to mind here. So the circular economy says that we can make best use of resources by keeping them at the highest possible utility for longest. And basically, if you can use a building as a building, that is the highest possible utilization of that asset. Yeah. If you have to start taking it apart or rebuilding it or extending it or adapting it, that's sort of a next tier. If you have to demolish it and reuse the raw materials, then you're at the bottom of the chain, if you see what I mean. So we're always trying to keep things at the highest possible utilization. The second bit, though, is that every country is in a different situation. So at one extreme, we've got Africa, where we've got to move from about 1 billion people to 4 billion people through the rest of this century, and at the same time create the urban environments that those people are going to want. So in that case, you can see there's a lot of new building going to be required, new infrastructure, new everything. So we've got to work out how to do that as carbon effectively as possible. At the other extreme, we've got places like Japan or Italy, which already have negative population growth, where you might expect, therefore, they probably have enough built environment already, although it may not be quite of the right type. So there it's about reuse and adaptation ahead of rebuild. And Australia is somewhere in the middle, I think, because there is still population growth through migration and through the benefits that you can have from being in Australia. And therefore, it's a bit of both. But I would still think about half the time, if we thought clearly and cleverly, we could reuse what we already have.
So if technology is fundamental to decarbonisation of the built environment, what would speed up the much needed adoption?
There are many answers to this, and I'm going to go through them quite quickly because it's so many. Right? The first one, I think, is simply an attitude. In other words, we all have to want to do this. The second one is an awareness of how to do it, the possibilities, how you go about it. The third one is about regulation, and I think the regulation does have a major part to play. It should actually be an instruction from our government to do this. And an example here is there's a move in the UK to introduce Part Z of the building regulations to monitor embodied carbon, which would actually stipulate how much carbon you should emit for a construction of a certain type. In the same way as we've already introduced what in the UK would be called Part L for thermal efficiency and insulation, and similar regulations exist in Australia. So there is a part definitely for regulation. There is then the financial interest. So what we've got here is the investors, the funders, are beginning to demand that we have particular performance requirements coming out of the things that they're investing in. So that also drives performance. And at the moment, actually, that's coming ahead of regulation. In other words, the funding requirements are here and now. The regulation's not yet arrived. And then the last one is establish common practice, common language, common standards, and common ways of talking about things and doing things. But that has to come, after we've changed our attitude, grown our awareness, and are actually doing it.
With 90% of our lives spent inside buildings, how important is Arup's focus on nature positive in completing the vision of sustainability?
So while we've been polluting the planet with carbon, we've also been significantly reducing biodiversity. So it's a double-sided problem. One side, we're putting more carbon into the atmosphere. On the other side, we've reduced the ability of the planet to absorb it. And there's also a moral thing here. We should be helping create a planet where all species can thrive into the future. So there's a moral imperative to restore this ecology, but also being nature positive, which means, by the way, simply improving the natural environment with whatever we do, is a sort of win-win, because it does restore biodiversity. It increases pollution absorption, including absorption of carbon. It increases resilience, so we can use it to mitigate floods and stormwater, for example. It increases the availability of renewable resources, from both food to biomaterials, things that we can use in construction, and it increases human well-being. We are actually part of nature. We sometimes think of ourselves as being a different thing, but actually we're not. We're natural things, and most of our senses are tuned to nature. So most of the things we find beautiful are because they in some way replicate the natural world around us.
The built environment certainly has an increased and much needed focus on decarbonisation, but how do we also adapt the built environment for the inevitable climate impact?
So we tend to refer to this as resilience. So we must make all aspects of the world more resilient to the shocks that nature is going to create through global warming. It's most relevant, I think, to infrastructure systems. So whether you talk about stormwater or electricity or transport, these have to be made resilient against these potential shocks. It's also relevant to communities and societal resilience. So how do we improve governance and other aspects of how we live, make more mixed communities so that they make better decisions in the face of adversity? And for buildings, it's perhaps a little less relevant, but it's still there. We still have to design for flooding, for increased wind loads, and most importantly, for the increased temperature that's going to come. We are still optimistic. Some of us are still optimistic. We might be able to get to 1.5 degrees and limit climate warming there, but it's more likely to be 2 degrees. And of course, these are global averages. Something between 1.5 and 2 degrees is going to look more like 4 or 5 degrees in Australia, for example, which is going to actually suffer more. So it is really important that while we try and reduce climate change as much as possible, we also design to survive the climate change which is going to happen. And while countries like Australia might suffer more than the global average, when we look at cities, we get more again because we get the urban heat island effect. So cities actually accumulate heat unless we design them with more nature, more light colours, and more thinking about the way that whole cities work. And then lastly, the important thing is to make the things that we do design, the buildings and infrastructure that we are creating, adaptable so that they can be changed to meet an unknown future, and they can be long-lived in their own right, and we can continue to use them.
Do you think that's why there's so much research into the benefits associated with having those natural materials around you in buildings?
Absolutely. If we can bring it into the built environment, inside our buildings, it's even better. So we get benefit, well known now, wellness benefits from plants, but we also get wellness benefits from timber, from stone, from other natural materials. And it's to do with this. Our brains were programmed, or our neuro whatever systems were programmed 100,000 years ago when we were hunter-gatherers out on the plains and lived in the natural environment.
How important is the principle of a circular economy for the built environment in your view?
So I've already mentioned that the idea of the circular economy is to keep things at their highest utility. Ultimately, it avoids waste, but that's at the lower end of the chain, if you like. The first thing is to try and keep things in use. And that partly depends on who owns what and what responsibilities they have. So one of the examples is in the car industry, car makers are now being held responsible for the life of their cars and repurposing and then ultimately recycling them at end of life. And what that does is keep the materials in the car, the elements, components, at highest utility, because they have to repair them first, if you see what I mean. We now have to bring that whole ability into the built environment as well. And it's happening. We're seeing recycled carpets being used, for example. We're seeing furniture being made out of old furniture, and indeed reusing existing furniture. So you can see that, reuse existing first, make things out of the same materials second, recycle the materials into different products third, and ultimately, dispose of them, but hopefully never. Nature doesn't dispose of anything. Every part of nature is a resource for another part of nature. So that's the model that we're trying to follow with the circular economy.
And how can we build for a regenerative future?
This is about restorative design and then regenerative design. This is about how we restore the planet to its health, planetary health, across nature, across consumption, about resources availability, as well as about human life. Everybody can win in this. We can have a better life and all other species can thrive, and we can stop consuming more than the planet can provide. But to get there, we have to create a planet which is capable of generating all the resources that we need every year. And that's what a regenerative future hopefully will look like.
When you consider the importance of the decarbonisation journey, building for resilience and nature positive building, how will technology affect industry moving forward from your perspective?
Well, the first point I'd like to make here, Anthea, is that the technology already exists. This to me is the good news. We had a technology sort of bubble about 10 years ago, which created tons of things that we are still learning how to use effectively. So you don't have to look for the new technology. In my view, at least in a digital world, we can use the existing. So we have mobile, we have social, we have cloud, we have big data, we have artificial intelligence and machine learning, we have user-centered design, we have augmented reality and virtual reality, and we have the Internet of Things, as well as our existing skills in simulation and building information modeling and others. So what I'm saying is that that's an enormous smorgasbord of opportunity that we just have to learn, work out how to use. We also need to use data to understand how things work and gain valuable insights from reality. We tend to, in the past, have relied on simulations to give us our insights, but we can actually get feedback from the actual built environment that can tell us how things are operating. We can continue to simulate and optimize whatever it is we're doing. We can connect the two together with things called digital twins that take information from the built environment and then work out how it could be operated more effectively and give that instruction. So it becomes a sort of self-fulfilling prophecy with data going backwards and forwards. So in my view, in summary, and this is something I believe passionately, if you like, we can and will design a better, more sustainable future using technology.
Would you agree one of the challenges is there's still not an efficient handoff of data post-construction for use in the operational, ongoing or lifecycle management of assets?
Absolutely. Couldn't agree more. So we've got to move away. Well, we've got to still have BIM models to help construction, but we've got to work out which parts of that model are used or would be useful in the construction of that digital twin to help with operation and asset management through the life cycle of the asset. The problem at the moment is the parties you're dealing with contractually are often different. The person interested in building it and the person interested in operating it are not the same.
Arup has enjoyed enormous success and is clearly leading the way in delivering projects and consulting services for a sustainable world. When you look ahead and think future, what is it that excites you the most?
As an engineer, I think we engineers have never lived at a better time, if you like, because there are all these major issues that need solutions, that they're big challenges that we can resolve. But the opportunity is there, despite the challenges, to create a better future for our children, our children's children, and all the other species on this beautiful planet. And I find that a tremendously exciting possibility.
Tristram, I think we're lucky to have people like you at the helm and lucky to be having organisations like Arup clearly leading the way in building a sustainable future. We thank you for being on the program.
Thank you, Anthea. It's been entirely my pleasure.
This podcast was brought to you by VinZero. VinZero help the AEC and manufacturing industries keep pace with digital change and achieve their technological and sustainability leadership goals. VinZero is a company that cares about creating and building a better world. Together, we are working with industry and environmental experts, providing forums and platforms through our VinZero Think community to create conversations that matter to our future generations. We invite you to join in the conversation and participate in our Think community. Like and subscribe to Think Future to stay up to date with the latest innovations and conversations as we take AEC and manufacturing around the world closer to zero. You can download our podcast at vinzero.com or from your favourite podcast platform. From VinZero Think Future, thanks for listening.